Okay, let us discuss the next problem. So this is 1.63. So basically in the last we have said some theory. So this is the use of last theory. So let me first make the diagram and then we'll discuss the problem. So we have an inclined plane, something like this, and there is an inclined plane, and here we have a pulley. There is a pulley here, and this pulley is basically attached by this inclined plane. Now there is a mass this side, mass m1, and there is another mass that is attached this side. This is mass m2. So let us make this mass is m1. Let us make this perfectly something like this. And now this is fixed on this surface. So base is fixed on earth. Are you getting? Now you have this angle is given to you. So this is alpha. This is m2. This is m1. So this is the diagram for this question. Now let us read the question. The following parameter as shown in the figure 1.11. So this is figure 1.11 are available. Alpha is given to you. Friction coefficient between this surface and this block is K, that is given to you. Masses of pulleys and threads are negligible. Initially system are moving from rest. What should be the condition on m2 by m1? So we have to find out condition in m2 by m1. So that first part A, so that object m2 starts coming down. So this is m2 starts coming down. Second part, m2 starts going up. So let us discuss first. M2 starts going up. So what will be the condition when m2 starts going up? This means this block has a tendency to go up, this block has a tendency to go down. This is same as m1 starts to going up, to go up, so go down. So m1 will go down. So what will be the condition that is required in this case? Now you see, in the last problem we have discussed the same problem. So you have to remember the theory from the last problem, then we can solve only this problem. So if you let us see the theory from the last problem. So if you see this theory, in the last case, we have said when m1 moves down, I have some theory we will discuss. Now this problem can be reduced. So if you see this problem, and what is the difference between these two problems? Here θ1 is equals to alpha. So in the last theory I have to replace θ1 by alpha. Now θ2, this angle in this case is basically 90 degree. Are you getting? So I can replace θ2 by 90 degree. Are you getting or not? So the last theory we have discussed θ1 by alpha, and friction coefficient is K1. Now here you have simply K. So K1 can be replaced by K. And now this surface is not in touch with this surface. So I can say K2 is 0. So I can also say K2 is 0. So this is the special case of last theory we have discussed. So what is the condition when m1 goes down? So we have condition here. So you see your copy, you will find this condition you have already written. So this is the condition when m1 goes down. So this is the condition for m1 goes down. So let us copy this condition again. So let me write. So m1 goes down, I have already derived a condition, and this condition is m1 sine θ1 minus m2 sine θ2. This should be greater than K1 m1 cos θ1 plus K2 m2 cos θ2. Now plug the value of, so sin θ1 in this case, θ1 is alpha, So this becomes m1 sine alpha. Theta 2 is 90 degrees, so this becomes m2 simply. This is greater than theta 1 is alpha, so this becomes k1 m1 cos alpha. And you see k2 is 0 and theta 2 is 90 degrees, so this term is basically 0. So this is the condition. Now let us take this m to this side, so I will have m1 sine alpha minus k1 m1, this is k1 m1 cos alpha. This should be greater than m2, or if we divide by m1, so I will have sine alpha minus k1 cos alpha. This should be greater than m2 by m1. So basically we have condition, that is m2 by m1 should be less than sine alpha minus k1 cos alpha. So this is the desired condition when this m1 will move down. Are you getting or not? Part B says what should be the condition so that m1 starts going up. So what should be the condition so that now this time m1 goes up? So you see, in the last case we have already discussed, if m1 goes up, what is the condition? You see, you can check your copy also. So you see, in the last case, so I am using the last result. If m1 goes up, we have derived a result in the last case. So this is the result if m1 goes up. So let me copy this result. You can copy from your copy also. So this is m2 sine theta 2. You can copy your result from your copy your own, minus m1 sine theta 1. This should be greater than k2 m2 cos theta 2 plus k1 m1 cos theta 1. So if you plug the value, theta 2 is 90 degrees, so sine theta 2 is 1, so this is m2 minus sine alpha, because theta 1 is alpha. This should be greater than cos theta 2 is 90 degrees, so this is 0, k1 m1 cos alpha. Now let us say if I take this term this side, so m2 should be greater than m1 sine alpha plus k1 m1 cos alpha. So I will have m2 by m1. This term should be greater than sine alpha plus k1 cos alpha. So this is the condition when basically the m1 goes up. Now the third situation is, so this is the condition number 2. So you have to derive the third condition when this m1 remains at rest. So you can see your notebook also, what is the condition when m1 remains at rest. So let us go third part. So now this time part C, that is m1 is in rest. You see your notebook, you will find there is a condition. So let me copy again. So this is the condition we have derived. Either I have to prove this condition, that the k1 m1g cos theta 1 plus k2 mg, this should be greater than mod of this. Or you can use these two conditions. If you use this condition and this condition, and then finally you can get the result. So let us apply these two conditions. You can also use this condition. Only thing is you have to take minus and then you can use the inequality. So either use these two conditions where f1 is this, f2 is this. So let me write f1 plus f2. So this value is greater than one time from this, another time from this. So I can reduce this whole equation into two equations. I can write one equation is k1 m1g cos theta 1 plus k2 m2z cos theta 2. This should be greater than, so equation number 1, that is m1g sin theta 1 minus m2z sin theta 2. Are you getting or not? Let us plug the value. So cos theta 1 is simply alpha. So you will have k1g goes out. So k1 m1 cos alpha. Cos theta is 90 degrees. So this term is 0. So this should be greater than. Sin theta 1 is simply alpha. So m1g. G is gone. So m1 sin alpha. And theta 2 is 90 degrees. So this becomes m2 simply. Sin theta 2 is 1 and g has already gone. So I can say, if I take m2 this side, so I can say m2 is greater than m1 sin alpha minus k1 m1 cos alpha. So this is m2 by m1 should be greater than sin alpha minus k1 cos alpha. So this is the first condition. Now let us apply the second condition. I think you have copied the top one. I can remove. So if I apply the second condition, so let us remove this one. You can apply the second condition. Have you copied this one or not? I think you have copied this one. So second condition in this case again. So let us say, if you see, I have applied this condition. Now I have to apply this condition that f1 plus f2 is greater than. So f1 plus f2 is k1 m1. This is k1 m1 cos theta 1 because I am cancelling z. So k1 m1 cos theta 1 plus k2 m2 cos theta 2. This should be greater than. So this is f1 plus f2. Now this time this should be greater than m2 sin theta 2 minus m1 sin theta 1. Now plug the value of theta 1 and theta 2. So theta 1 is alpha. So this is k1 m1 cos alpha. Are you getting? And k2 is 0. So this should be greater than m2 sin theta 2 is 90 degrees. So this is greater than m2 sin theta 1 alpha m1 sin alpha. So I can write. So this value, if I take this side, so k1 m1 cos alpha. Are you getting? Plus m1 sin alpha. This is greater than m2. So if I divide by m2, so I can write k1 cos alpha plus sin alpha. This should be greater than m2 by m1. So I can say m2 by m1 should be less than k1 cos alpha plus sin alpha. So let us say this equation is equation number 2, and this is the previous condition, that is equation number 1. So in this case m2 by m1 should be less than this thing, and in this case m2 by m1 should be less than this thing, and in this case this is greater than. So I can have a condition on m2 by m1. So m2 by m1 should be less than this value, that is k1 cos alpha plus sin alpha, and this value should be greater than. So you see, are you getting it? So we are saying m2 by m1 should be less than using this value, and m2 by m1 should be greater than, you see here, this value. So that is sin alpha minus k1 cos alpha. So this is sin alpha minus k1 cos alpha. Basically in this case k1 is equals to k everywhere, wherever we have written k1, that is basically k. So if you want, you can replace k1 with k, or you can leave this thing. K1 is basically k in all cases. So this is the condition when the two block remains m2 by m1. So when the two blocks remains at rest. So you can check the conditions. So let us copy this fast and then we will discuss the conditions. I think you have copied this one. So if you have not copied from top, let us copy. Please do fast. Okay, I think you have copied this one. So this is a fairly easy problem. You have to see the last theory, that is important one. How we have derived these three conditions. If Mn goes down, if Mn goes up, if Mn remain at rest. So in the last case, how we have derived? We have derived this theory using the fact in one case it has a tendency to go down. In that case, friction force will act in the opposite direction. So to move in going down, so I have to have the force that is in the downward direction, that is the driving force for motion, should be greater than the total friction force. Are you getting? And the second condition, a driving force in the right direction should be greater than the friction force in the left direction. This we have derived in the last class, or you see it here. So this kind of diagram you have to make basically, and then you can solve these problems. Okay, let us go for the next problem.